Today on Capecchi's Corner, we're going to look at the isosceles theorems. Let's remember what an isosceles triangle is. The definition states that it is a triangle with at least two sides congruent. So it could have two sides or three sides congruent. So we usually refer to an isosceles triangle with a triangle with two sides congruent. Since a triangle with three sides congruent is called an equilateral triangle, it has a more specific name. Now, at the top here, we have our vertex angle. And that's the angle that is across from the base. Our base is at the bottom there, and again, it depends on which way you have the triangle turned. The base angles are both close to the base, and in blue there are legs. They are considered the congruent sides. Now, the isosceles triangle theorem states that if two sides of a triangle are congruent, then the angles opposite these sides are congruent. So if we look at our given triangle, and we have our legs that are congruent, so here's a leg and that's a leg, and there are congruent sides. It says the angles that are opposite these sides are congruent. So the one opposite that leg would be this one, and here's the angle opposite the other leg. So these are actually our base angles, and they are congruent. Now, the isosceles triangle theorem has some corollaries that go along with it. So the first one states an equilateral triangle is also equiangular. We've actually seen this one before. An equilateral triangle is a triangle that all three sides are congruent. So if that's the case, we know that it's also equiangular, meaning all three angles are congruent. In corollary 2, it says an equilateral triangle has three 60-degree angles. And the last corollary, corollary 3, this is a big one. We see this a lot. It says that the bisector of the vertex angle of an isosceles triangle is perpendicular to the base at its midpoint. That's loaded with information. So it says the bisector of the vertex angle. So basically I know if I bisect my vertex angle, it's going to be perpendicular to the base at its midpoint. So that also means what I just did was I made this base just divided into two equal parts. The converse of the isosceles triangle theorem is the opposite. It says if two angles of a triangle are congruent, then the sides opposite these angles are congruent. So in this case, we're given congruent angles first. So this angle, our base angles, are congruent. And it's saying that the sides opposite these angles are also congruent. So that makes that a side congruent to that side. There's also a corollary with this theorem as well. It states that an equiangular triangle is also equilateral. Now remember, equiangular means all the angles are congruent, and equilateral means that all the sides are congruent. So we're stating here with this corollary that if the angles are all congruent, then the sides are congruent as well. Now let's practice applying these theorems into some diagrams. So if I look at triangle XYZ, I have two congruent sides. XZ is congruent to ZY, which makes this an isosceles triangle. So an isosceles triangle theorem, we know that the sides are congruent, the angles opposite those sides are also congruent. So that means I can say that 5t minus 13 is equal to 3t plus 3, because angle x is congruent to angle y, which also means that these angles are equal. So let's solve this. Subtract 3t from either side, and I have 2t minus 13 is equal to 3. At 13, I have 2t is equal to 16, so I know that t is equal to 8. Now, it's always a good idea to double check my measurements, and I can even find the measure of angle z with the given information. So the measure of angle x is going to equal 5 times 8 minus 13, and that equals 27. So the measure of angle x is equal to 27. Now the measure of angle y should also equal 27 if we did our math right, since they are base angles and they're congruent. But let's try. So there's my measure of angle x. My measure of angle y is going to equal 3 times 8 plus 3. So again, that's 3 times 8 is 24, plus 3 is 27. So that looks good. Now I can find the measure of angle z even though there's no label there. I know that the triangle has a sum of 180 degrees, all the interior angles. So if I subtract 27 and 27, I know that the measure of angle z is equal to 126. And looking at our next example, we have the measurement of angle L is 82. And again, I know that the sum of the interior angles of a triangle is 180. So if I take that, 180 minus 82, I get 98. At this point, then, I'll divide it by 2 because I know the angle J and angle K are going to be congruent because they're opposite the congruent sides. So that gives me 49. So I know that the measure of angle J is going to equal 49. And also I know that the measure of angle K is going to be equal to 49. Now I can double check my work to make sure that 49 plus 82, which is given, equals 180 degrees, which it does, so I know that I'm all set with my given measurements. Now in our next example, we have angle A is equal to 4x, angle C is equal to 2x, and I also know that angle B has to be equal to 2x as well, because again we have isosceles triangles, so those base angles are going to be congruent. Now how do I find the measurement of each angle? Well, again, I know that the sum of the interior angles of a triangle are 180. So in this problem I'm going to go 2x plus 2x plus 4x is equal to 180. If I combine what I have on the left hand side, that gives me 8x is equal to 180. Divide both sides by 8. Now x is equal to 22.5. Now sometimes that makes people nervous when you have a decimal, but let's just keep going and see if it works out okay. So the measurement of angle A is going to equal to 4 times 22.5, which actually equals 90. And the measure of angle C is going to equal 2 times 22.5, and that is equal to 45. Now I know the measure of angle B is going to be the same, that's also 45. So here are my measurements. Measure of angle A is equal to 90, measure of angle C is equal to 45, and the measure of angle B is also 45. Now I can double check my work to make sure that 90 plus 45 equals 180, which it does, so I'm all set. And looking at our next example, again, there's my congruent sides here. And I have angle B, the measure of angle B is 6y plus 1, so I know that's also true for letter A, is also going to be 6y plus 1. The measure of angle C is 21y plus 13. So again, because we know the sum of the interior angles of a triangle are equal to 180, let's set that up. So 6y plus 1 plus 6y plus 1 plus 21y plus 13 is equal to 180. Now again, here's my wall. Combine what I have on the left. So I have 6y and 6y is 12y plus 21y gives me 33y. I combine all my constants and I get 15. That equals 180. If I subtract 15 from both sides, I have 33y is equal to 165. Divide by both sides by 33, and y is equal to 5. Now at this point I can find the measurement of each angle. So again, the measure of angle B is equal to 6 times 5 plus 1. So the measure of angle B is going to equal 31. The measure of angle A will be the same. And let's do the measure of angle C. So we have the measure of angle C is equal to 21 times 5 plus 13. So 21 times 5 is equal to 105, plus 13 gives me 118. So the measure of angle C is equal to 118. Now again, we can double check this by making sure that 31 plus 118 is equal to 180, which it does. So we're all set. There's our measurements of our three angles. In this next triangle, I have two angles that are equal to 40 degrees. So that makes the sides opposite those angles also congruent by the converse of the isosceles triangle theorem. So that means 5x minus 8 is equal to 2x plus 7. If I want to solve for x, I have 3x minus 8 is equal to 7. Add 8 to both sides, and I have 3x is equal to 15. So x is equal to 5. Now if I want to double check this, I can substitute that back into either side, and I should have congruent segments there. So I have 5 times 5 minus 8, which gives me 25 minus 8. So that segment is 17 units. Do the same thing with the other side, 2x plus 7. Substitute that 5 in. And I have 10 plus 7, which also equals 17. So I knew I did that correctly. So again, by the converse of the isosceles triangle theorem, if the angles are congruent, the sides opposite those angles are also congruent. In our next triangles, we have actually two triangles here, both isosceles. So I have to figure out what I have. In my top triangle right now, I know that my vertex angle is 98. I also know that these angles here are going to be congruent. So let's figure out what they are. So if I take 180 minus 98, I'm left with 82. But I know that I have two angles and they are congruent, so I divide both sides by 2. And those angles are going to be 41 degrees. So this is 41, and that's 41. Now if I look at my triangle below that, I don't have any angle measurements, although I do know that I have an isosceles triangle. So I have to figure out what I need to do with this. Now I do have a marking in that this side is congruent to that side, and also on my lower triangle, those are also congruent. So they're all congruent to each other. Now if I look at this middle piece, this middle line, that's congruent by the reflexive property. So I actually have these triangles are congruent by the side, side, side postulate. So once I've proven that, I know the angles are going to match up and the sides are going to match up because of CP/CTC. Corresponding parts of congruent triangles are congruent. So again, this x is going to be the same as that other angle, again because they're across from the sides that are congruent. So I know that x has to equal 41 degrees because that will match up with the angle on the top triangle. And looking at our last example for today, again, I notice I have isosceles triangles. So it means this angle is congruent to that angle, but I don't have any measurements within that triangle. However, I do know that I have 2x here and I have a 90 minus x there. So how does that help me? Well, I have some markings here. I have parallel lines. So with parallel lines, I know that alternate interior angles are congruent. So this 2x, there's my transversal. I'll make that in red. My transversal is right here. So this 2x is going to be congruent to this angle right there. And my 90 minus x is also going to be congruent to that angle right there because they are both alternate interior angles. Again, the second set of angles, I'm using that transversal there. So I can say because of those parallel lines and the alternate interior angles are congruent, I can say that 2x is equal to 90 minus x. Bring my x to the other side, and I have 3x is equal to 90, and x is equal to 30. Now again, I like to check. So if I have 2x and I substitute that 30 in, I know that measurement is 60 degrees. I can do the same thing with my other angle, 90 minus 30, and I also get 60 degrees. So again, these base angles are each equal to 60 degrees.